lesson about the equation of a line. So this is a topic about analytic geometry. When we study analytic geometry, it's always best to visualize what you are doing, what equation, what geometric figure is actually equivalent to a certain equation, but the geometric figure depends on the degree. So if the degree of your function, which is the highest exponent of your x, is 1, then it's a line. If it's 2, it's a parabola. If it's 3, it's a cubic function, and so on and so forth. Alright, so when you're forming equations of lines, the first thing that you should always remember that x and y here are not replaceable. Okay, only the letters apart from x and y. So in the equation of a line, we have the variable m. What's the meaning of that variable? We have the variable b, and then we have x1 and y1, which constitute a point, and then you have this a. And what is the meaning of all of this? So the slope is m, and it's the inclination of a line. It tells you where your graph is slanting. So whether it slants to the right, it's positive. So the graph looks like that. It slants to the left, it's negative. If it's a horizontal, the slope is 0. And if it's a vertical, the slope is undefined. So it depends on your slope, where your graph will be inclined or where your graph will not incline. So of course, if your slope is 0 and infinite means that it doesn't have a slope, or the slope is 0. Then what about b? So b is the y-intercept. So when we talk about y-intercept, this is where your graph will intersect the y-axis, therefore making x equivalent to 0. So example of a y-intercept is 0, negative 3. It means that at y at negative 3, it will intersect the y-axis. So this represents a point. So in analytic geometry, an ordered pair is automatically a point. And let's say, for example, you have 3 and negative 4. So this is a point. The geometric figure for this is a point. Now, A represents the x-intercept. And the x-intercept is when your graph intersects the x-axis. So it's represented by A0. For example, 4, 0. So it means that the graph will intersect your graph at 4, okay, at x equals 4. So these are the things you need to remember to find an equation of a line, because as I'm always saying, mathematics is also vocabulary by itself. Okay, now let's start forming equations of lines, and then afterwards we will generalize and summarize everything. What if everything is how to identify whether I'm using a certain form of the slope intercept or point slope or intercept form. Okay, so let's say the slope of a line is 2/3 and the y-intercept is negative 5. So this means that the graph is passing at 0, negative 5. And it's always best to draw the line so that you can visualize it. Not only memorize it, but you know how to visualize it. So you have 0, negative 5. So the graph passes through at 0, negative 5. And the slope is 2/3. And we know that the slope is rise over run. And so therefore, the rise is 2. It means the graph from the y-intercept will go up by 2. And then run is 3. So that's going to the left and right. So this is positive. So it goes to the right. So I always say that after you go up or down, you just go to the right side. So it means that just keep the denominator positive, and the numerator could either be negative or positive. So we go up by 2 and then 3 points to the right side. And then of course you dot the rise and the run, like making a right triangle. And then 2 points determine a line, so just connect the 2 points. So this is actually the line that we are referring to. And in analytic geometry, it's really important to label our equations. So now we still don't know it, but because you have the slope and you have the y-intercept, you can use y equals mx plus b. And at the end, it's always advisable to put it in standard form. So just plug plug in m, it's 2/3, and your b is -5, so just put -5. All right, so remember x and y are not replaceable, only m and b. So these are the constant values because the x and y here depends on all of this. There are infinite values of x and y here. Okay, so after that, we put this in standard form, so we remove the fraction by multiplying everything by the denominator of the fraction, that is 3. So that's 3y equals 2x minus 15. So 3 cancel out, that's 2. And 5 times 3 is 15, 3 times y is 3y. And because I'd like to keep the x positive, I'm going to remove 3y and move it to the other side. So when you move a term or a number, you need to change the sign. We call it the transposition method. So I'm not moving 2x because it's already positive by itself. So I will move 3y, it becomes negative, and 15 now becomes positive on the right side, on the left side. Now, because of the symmetric property of equation, I can actually switch this, but when you switch, you don't change the sign. It's only when you transpose a particular expression that you change the sign, but when you switch, we call this the symmetric property of equality. Okay, you don't change the sign, okay, but you use transposition here. So when you transpose just a particular part of your equation, when you use symmetry, you switch the whole and the left side. So this is now the standard form. Your c is 15, your b is -3, and your a is 2 in the standard form of an equation. Okay, now let's go to the next form of an equation. So let's say I have a slope 5 over 2 or -5/2, and I have a point -1 and 4. Okay, so let's graph what our problem means. So your graph passes through -1 and +4. So like right here. And then from the point, it's not about the intercept this time. From the point itself, we will illustrate the rise and the run. So -5 is your rise, so we will go to the left. We will go down, I'm sorry. And then after that, over 2, we will go to the right side. So I always say, just keep going to the right side in your denominator, so your numerator tells you whether you go up or down first. So from +4, so you move down by 5, 1, 2, 3, 4, 5. Okay, and then you go to the left by 1 point, so that will be here. Okay, so you see, you illustrate a right triangle and just connect the points of the hypotenuse of the right triangle. Okay, so that is the line. And what is the equation of this line? Because I have a point, I have a slope, and I have a point. So this is the slope and I have a point. Okay, we will use the point slope form, which is y minus y1 equals mx minus x1. So meaning to say, this is the x1 and this is the y1. So what should we do? We simply plug in y minus 4 is equal to, the slope is -5/2, x minus -1. But because negative times negative is positive, you can make it positive later on. Okay, now we will multiply the whole equation by 2. Okay, because you'd like to put this in standard form. And when you do that, you multiply each of the term by 2 except the ones inside the parentheses, only the outside. So 2 times y is 2y minus 8 is equal to -5x plus 1, because negative times negative is positive. And remember, I will divide 2 by 2. It cancels out. So you have -5 as a remaining. So we have to free x because we're putting it in standard form. So we will distribute -5 to x plus 1. So remember, both of them. So it's a common mistake of students. They only multiply it with the x. You should also multiply it with 1. So 2y minus 8 equals -5x minus 5. Now remember, we would like to keep x positive. And so therefore, we need to move x this time, okay? And not y. So we will move negative 5 and we will move negative 8 at the same time, okay? Because the constants should be on the right side, the letters should be on the left side. So therefore, I have 5x plus 2y is equal to negative 5 plus 8. So 8 becomes positive and 5x becomes positive. We transpose them. This is not symmetric. If I will just switch these places, I will not change any of their signs. So I have 5x plus 2y is equal to 3. Okay, I forgot to check the answers from the previous, but we will check the answer here. Because we know that this is a point along the graph, it should satisfy the equation. So where x is negative 1 and where y is positive 4. So to plug in, you have 5 negative 1 plus 2 times 4 equals 3. Okay, so negative 5 plus 8 equals 3. And as you can see, 3 is equal to 3. So if a point passes through a graph, it means it will satisfy its graph. That's the reason why when you plug in the value of x in the equation, it makes it true. So that's how you check whether your answer is correct or not. Okay, now we will go to the next one. We call it the intercept form. So given the intercept, so supposing I have 2 points, negative 3, 0 and 0, 4 that passes through the graph of a line. So as you can see, you have here a 0 and you have here a 0. It means that this is referring to an x-intercept where it is represented by the small letter a, and your y-intercept is 4. So if you're going to graph your line, it's always best to graph your line so that you can check it later if you're doing the right thing or not. So when you graph the line, so you have negative 3, 0, and it's here, and then 0, 4, and it's here. Okay, so that means our slope is positive since the graph is actually slanting to the right side. So let's see later on if that's really the case. So since I have two intercepts of the line, I have x plus over a plus y over b is equivalent to 1. So you plug in the numbers, x over negative 3 plus y over 4 is equal to 1. Okay? And so therefore, we need to put this in standard form. Because this is negative, we will multiply negative 12. Okay, let's say, for example, you keep it at 12. Now, why do I multiply by 12? 4 and 3 are relatively prime. It means their common factor is just 1. If that happens, the LCD is just the product between the two. 3 times 4 is 12. And so you have 12 divided by negative 3 is negative 4. Multiply it to x, it gives you negative 4x. 12 divided by 4 is 3. And then multiply it by y, so it gives you 4y. 3y is equal to 12. And of course, you would like to keep the x negative, so we will need to multiply this by negative 1. So you have positive 4x minus 3y is equal to negative 12. Now, how do we check if the answer is correct or not? Of course, one of the points should satisfy this condition. For example, I will use negative 3, 0. It means that my x is negative 3, my y is 0. So you have 4 times negative 3 minus 3 times 0 should be equal to negative 12. Alright? And as you can see, this is 0, negative 12 is equal to negative 12. If a point satisfies the condition of the line, therefore, that point is passing through the line. Now, I said that the slope of this is 0. Your slope is defined by the equation y2 minus y1 over x2 minus x1. And of course, if this is your x1, this is your y1, this is x2 and y2. So you will have 4 minus 0 all over 0 minus negative 3. Then, of course, this will be 4 divided by positive 3, since negative times negative is positive, and therefore the slope is 4/3. So remember also this formula to find the slope. This is actually where the point slope form was derived. You see, if I'm going to cross multiply, I will cross multiply. I will have mx2 minus x1 is equal to y2 minus y1, which is actually the point slope form of the equation of a line. So you see, everything about a line is actually about the slope. Okay, if you know the slope, you can characterize an equation of a line. Okay, now the last one, what if I have 2 points? For example, 5, -2, and I have -1 and 3. Alright, and of course, if we graph this line, you have 5, -2, 1, 2, 3, 4, 5, and you have it here, and then -1, 3, and you have it here, and 2 points determine a line. You can actually connect the 2 dots, you form a line, okay? But what is the equation of this line? And of course, since the line is slanting to the left, it means that the slope should be negative, okay? So, remember we don't have a 2-point form here, but we have just a point slope form. It means that we can find the equation by finding the slope first. Okay, and then choose any of the 2 points to plug in. So let's say we find the slope. Let's say this is x1, y1, x2, y2. I will erase this. It's going to be a long solution. So we find the slope first, which is y2 minus y1 over x2 minus x1. And y2 is 3 minus -2 all over -1 minus 5. So it gives us 5 over -6, which this becomes 3 plus 2. And as you can see, the slope is a negative value, which is negative. You can also write it as -5 over 6. So because from the previous illustration, the slope of this line should be negative because the graph is slanting to the left. So you have a slope already. And you even have more than 1 point. You have 2. You can choose any of them. Let's say I already put it as 5, -2 as my x1 and y1. I'm going to use it. Okay, and of course, the point slope form of the equation of a line is this form. Remember, x and y remains to be x and y. All the other things can be replaced. So you have y minus -2 because that's y1 is equal to -5 over 6 x minus 5. Okay, so you will have now y plus 2 equals -5 over 6 x minus 5. And so, of course, we need to put this in standard form by multiplying the whole equation by 6 because we need to free x. Okay? If we multiply by 6, the fraction is cancelled. This now becomes 6y plus 12 is equal to -5x minus 5. Remember, just multiply the 6 to -5 over 6. This is cancelled out. You have -5 as remaining, but remember, you also need to multiply it to y plus 2. And so we can free x here. So you have 6y plus 12 equals -5x. Okay, distribute properly. It's positive 25 because negative times negative is positive. So you have now your x should remain positive. So therefore, we need to move it here and we need to move 12 on the other side. So therefore, it now becomes 5x plus 6y is equal to -12 plus 25. Okay, making our standard form to be 5x plus 6y is equal to 13. Now, how do we know if we did the right thing? Okay, how are we sure that we were able to find the equation correctly? Okay, now remember, we have used 5, -2 as our point to find the equation of a line. To be sure that it's correct, we will use this to plug in and make sure that this also passes through the line. So you have your x to be negative 1 and your y to be positive 3 should be equivalent to 13. So this is negative 5 plus 18 equals 13. And as you can see, negative 5 plus 18 is also 13. So therefore, what we did is right. So when you have 2 points, find the slope first, choose one of the points, plug in the point slope form, and then when you want to check it, use the other point to check whether you did the right thing. Okay? And so, if you have a vertical line, like you have your line here, okay, and you have 5 here, the graph has an equation of x equals 5 because it intersects the graph at x equals 5. But if you have your negative 5, okay, this is y equals negative 5 because it intersects your graph at y equals negative 5. So horizontal line has y, they're opposite, and the vertical line has x, which is actually the last one. Okay, now, so therefore, we will summarize. And by this time, I hope that whenever you have certain conditions, you know the equation of a line to be used. So let's say, for example, I said you have a slope is, the line is passing through 5, negative 4, and 2, 0. I have here an x-intercept, but this is not an x-intercept. So I cannot use the intercept form. I can only use the point slope form. So therefore, we need to find the slope. So that's 0 minus negative 4 over 2 minus 5. So you have 0 plus 4 over negative 3. It's negative 4 over 3 is the slope. After that, we choose one of the points because this is easier. So don't make things difficult for you. The simpler, the better. So I'm going to use 2, 0 as my x1, y1. So you will have now y minus 0 equals negative 4 thirds x minus 2. So as you can see, this is cancelled. And if you multiply by 3, so you have 3y equals negative 4x minus 2. Notice that it's always cancelled out and we just have to distribute that. So 3y equals negative 4x plus 8 because negative 4 times negative 2 is 8. And of course, we always want to keep x to be positive, so we will move it to the other side and you have this. Okay, now let's see if we did the right thing. We will use this to check the answer. So 4 times 5 plus 3 times negative 4 should be equal to 8. And as you can see, this is 20 and this is 12 and both of them will be 8. So we did the right thing. Okay.